Hello everyone. On this video we will be looking at three-dimensional coordinate systems. Okay, so before we go into three-dimensional coordinate systems, we're going to take a quick look at a two-dimensional plane. Okay, so this should look pretty familiar, just your XY axis. Okay, so this is your two-dimensional plane. Okay, and that 2D plane is separated into four quadrants. Okay, so you have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so everything you did on an XY axis, you did on a two-dimensional plane. Okay, now to look at a three-dimensional plane, to really understand it, remember here you have your XY axis. Okay, so the first thing we're going to do is just think about erasing quadrants 2, 3, and 4 to where you just have quadrant 1. Okay, so I'm just kind of crossing those other quadrants out. And we're going to get that and we're going to kind of flip it around. Like this, to where this is your x-axis and this is your y-axis. Okay, just from that quadrant 1. Alright, so what I want you to do from there is I want you to visualize the corner of a room. Okay, so look in whatever room you're in, look at a corner. Okay, so if you have your x and your y-axis, imagine this is your floor. And going up the wall is your z. Okay, so looking at that, this is now your 3D plane. Okay, now look, like I said, just imagine you're looking at the corner of a wall. Again, this is the floor, and that goes up the wall. Okay, so now your 3D plane is separated. Oh, let me give that a little more room because I have to do some more drawing. So you may want to put this writing on the side. 3D plane is separated into not 4 quadrants, but 8 octants. Okay, we kind of clean that up. There we go. Okay, so you're probably looking like, okay, how is that separated into 8 octants? Let me show you how. You have z here. Now, if you notice for your 2 dimensions, you have x and y and negative y. Here, same thing. You have x, but if it kept going, that would be negative x. You have y. That kept going. That would be negative y. And you have z. And that would be your negative z. Okay. Now the same way this looks like just your XY axis. Imagine this, but now you have a lower right in the front, lower right in the back. Then you have the upper right in the front, upper right in the back. And you have the lower left in the front, lower left in the back. You have the lower left up top, or the upper left in the front and upper left in the back. So you have 8 quadrants here that you just separated this into. Okay, so this kind of is just an explanation of it, but most of our work will just be done in that first octant. Okay, this is to kind of give you a visual of what we're working with in 3 dimensions. All right, so if you are still writing, feel free to press pause. We're going to go to our next page. All right, so drawing another 3-dimensional plane. It's our X, our Y, and our Z. Again, if you picture it as like the corner of your room, that helps. Okay, so since we're in the first octant, the same way as in quadrant 1 and 2 dimensions, your first octant, all the coordinates are positive. Okay, so right now we're just looking at that first octant. All right, now this plane here, the one that, if you're imagining the corner, the part that's the floor, that's your XY plane. Okay, so again, if you're looking in the corner, now if you look at the right wall, going up the wall, if you look at the right wall, that's your YZ plane, because of course that's the Y and the Z. Okay, now if you look at the left wall of your corner, that's your XZ plane. Okay, now your X is actually your directed distance from the YZ plane. Okay, so your YZ plane, remember, is that right wall. Your X value, so let's say if you have X equals 2, if you put a 2 right there, then that 2 will be the distance from that YZ plane. Okay, now your Y, that's the directed distance from your XZ plane. Okay, in other words, the distance from your left wall. Okay, now your Z, if you look at your floor, the Z is the distance almost like from the floor. So the Z is the directed distance from your XY plane. All right. So hopefully that visualization helps to picture it as that corner. Okay, but now let's do a quick look at how 2 dimensions and 3 dimensions kind of differ. Okay, so for example, in 2 dimensions, bring that up a little bit. Let's say if we have our XY axis, we have our X, we have our Y. Let's say you wanted to graph Y equals 3. Now Y equals 3 is just a horizontal line through 3. So this is Y equals 3, if this is your 3 right there. Oh, let me clear that up, that's a little bit too close. Okay, Y equals 3, there we go. A little more space. Okay. Now in 3 dimensions, if we have our X, Y, and Z, Y equals 3 is that spot right there. But in 3 dimensions, it's not a line. It's actually a plane. So if you look at it this way, and excuse my drawing because I am not the best, but hopefully you get the idea. And let me see if I can make that a little bit clearer there. There we go. Okay, so kind of imagine a sheet of paper and that kind of going through the sheet of paper at that particular point. So if you're going to visualize it, kind of visualize, I'm going to cover it for a second, like this pencil going through that sheet of paper. That's where the pencil's poking through, and this is the sheet of paper. Okay, so this is how y equals 3 will look in 3 dimensions. Kind of like just that sheet of paper, but it keeps on going and going forever and ever, up, down, side, side. Okay, so what if we had, again, in 3 dimensions, we have our X, our Y, and our Z. What if we wanted to graph Z equals 2? Okay, so if we have our Z equals 2, and let's say, just for the sake of argument, that this point right here is 2. And we basically will have a sheet of paper going through that particular point as Z equals 2. And of course we can draw the sheet of paper bigger and bigger and bigger, but since we're kind of limited on space on this sheet, we're going to just draw a little thin sheet of paper going through the point Z equals 2. Okay, so what does this tell us? In 3 dimensions, we can say a couple of things. In 3 dimensions, X equals some value of K is parallel to the YZ plane. We'll move that over a little. Okay, so if we had X equals 3, then that would be a sheet of paper parallel to the YZ plane. Okay, so X equals 3 would be a sheet of paper right through there, and it would be parallel the same direction as the YZ plane. Okay, now if we had Y equals some value of K could be 1, 2, 3, 4, 5, 2.5, whatever. It could be any value at all. Okay, that is parallel to the XZ plane. Okay, now that may be a little easier to visualize because this is what we have here. We have Y equals 3, which is parallel. Remember, this is our XZ plane over here. So this sheet of paper will be parallel to our left wall, or our XZ plane, where our X equals some value. So if we had X equals 3, it will be parallel to our right wall. So it will be the same direction as our right wall. Okay, so you have a wall here and a sheet of paper going in the exact same direction. And Z equals some value of K. Like I said again, K could be any number we pick. That would be parallel to the XY plane. Or in other words, it's parallel to the floor. So if we got a sheet of paper and put it right through that point, it would be parallel to the floor. So it would almost, if you put a sheet of paper on the floor and that sheet of paper, they would be going in the exact same direction. All right. So hopefully this is a little bit clear. Said no thanks to my horrible drawing, but I'm trying. Okay. So if you're still writing, feel free to press pause. But we're going to go ahead and move to our next sheet. Okay. Points and the three-dimensional plane are denoted by the ordered triple we'll say the point we'll call X, Y, and Z. Let me clean that Z up a little. Okay, so we have our X, Y, and Z. That's our ordered triple. If you remember, your X, Y is an ordered pair. That we've been using so far. Okay, so that's your ordered pair. So since you have 3 points, that's your ordered triple. And again, sometimes the P won't even be there. Sometimes it will, sometimes we just call it point P at X, Y, Z. Alright, so again, if we draw our three-dimensional corner of the room, we have X, we have Y, and we have Z. Okay, so let's say if we have our X1 is right here. So whatever our X1 is, we'll say that's here. Now let's say whatever our Y1 value is. So whatever value of Y is, we'll say there. And let's say we have a third value of Z, which means that's where we'll go up. Okay, so this point is X1, Y1, Z1. Okay, so it went up X, to the right Y, and then, well, to the left X, to the right Y, and then up Z, number of spaces. Alright, so what if we had a second point? So let's say if we have another X value here, another Y value here, and we go up another Z value. Okay, so let's say if we make this point number 1 and this point number 2, that we'll make X2, Y2, Y number 2, and Z number 2. Okay, so we have our point number 1 and our point number 2, both on the same plane. Okay, now why do we do that? Because, well, what if we wanted to find the distance between those 2 points? Well, let's look at what we know already. Okay, now if you remember, that distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared in 2 dimensions. So in your 2D formula, this is what you use to find the distance. And your midpoint formula was actually equal to x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Okay, and we also knew that the center of a circle was HK, but that was for the equation of a circle x minus h squared plus y minus k squared equals r squared. Okay, so these are all the things we had for 2 dimensions. We had our distance formula, we had our midpoint formula, and we had our center of a circle. Okay, now in 3 dimensions, they don't really change all that much. Now in 3 dimensions, that distance formula, which remember that's the distance between point 1, point 2. Okay, and we'll cover that. This means the distance. Some books may have 2 lines on both sides to show distance, but we'll just use 1. Okay, so your distance is equal to the square root, and I'll just use the arrow there instead of all those equal signs. Okay, so you have x2 minus x1 squared plus y2 minus y1 squared, which is the same here, but in 3 dimensions, it's just plus z2 minus z1 squared. Okay, so the exact same thing, but you take into account that you're going up z. Alright, so what about the midpoint formula? Well, hopefully you're starting to see the trend. So if you have your midpoint formula, you have x1 plus x2 divided by 2, y1 plus y2 divided by 2, which is the exact same for up here. But you have your z1 plus z2 divided by 2. Alright, which leaves us with our center of a circle, but the only difference is in 3 dimensions, we don't have a circle, we have actually a sphere. Okay, so the equation of a sphere is really similar to the equation of a circle. It's x minus h squared, I'll put the arrow, plus y minus k squared, plus z minus, I'll use L, I can like cursive L, squared equals r squared. Okay, and the center is HKL, where the center of a circle is just HK, the center of a sphere is HKL. Okay, so as you can see, if you know the 2-dimensional equations here, it's not too difficult to find the three-dimensional equation. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and go to our first example. All right, so let's say, for example, we want to find the distance between the point 2, -1, 3 and 1, 0, -2. All right. So to go ahead and solve this, I'm just going to rewrite our point. Let's say 2, -1, 3, 1, 0, -2. Okay. Now it doesn't matter which one you make which, but we'll just, for the sake of simplicity, make this our x1, y1, z1, and our x2, y2, z2. Okay, so we have all of our points right there. All right. So let me ran out of pencil lead here. Let me get a little more. There we go. All right. So remember our formula for the distance. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. All right, so all we do, plug in our values. We have the square root x2 minus x1, so we have 1 minus 2. 1 minus 2 squared. We have our y2 minus y1, so 0 minus -1. 0 minus -1 squared. We have our z2 minus z1, so we have -2 minus 3 squared. Okay, so we go ahead and simplify this. So that's the square root. 1 minus 2 squared is negative, well, 1 minus 2 is -1. -1 squared is 1. Plus, I didn't need it this far over. There we go. 0 minus -1 is +1. So +1 squared is just 1. And -2 minus 3 is -5. -5 squared is +25. So we have 1 plus 1 plus 25, so we have square root of 27, which simplifies to 3 square root of 3. Alright, and in case you're a little rusty on simplifying your square roots, I'll do a quick little showing to show you how I got there. So you have square root of 27. Now, 27, you can make that 9 times 3. Equals square root of 9 times 3. Now you have two factors. You can separate those underneath the square root symbol. So that's square root of 9 times square root of 3. Square root of 9 is equal to 3, so you have 3 square root of 3. Just in case you were a bit rusty on your square roots. Alright. So if you are still writing, by all means, feel free to press pause. But we're going to go ahead and go to our next example. Alright, so let's say, for example, find the standard equation of the sphere with the points. We have 5, -2, 3, and 0, 4, -3 as endpoints of the diameter. Okay, now by endpoints of the diameter, to kind of help you visualize, what they're saying is if they have a sphere. Okay, so if you have a sphere, and excuse my horrible drawing, but pretend that's a perfect circle. So if you have a sphere right in the middle, like I said, just think about if that's like a perfectly round sphere. One point would be this point here, and this would be the other point. Okay, so the first thing we want to do is we want to find the center. So if these are the ends of the diameter, then our center will be the midpoint. Okay, so we're going to use the midpoint formula first to find the center. So if we can find the center, then that means we can go ahead and find the equation. Okay, so use the midpoint formula to find the center. Okay, so we know that midpoint is equal to x1 plus x2 divided by 2, y1 plus y2 divided by 2, and z1 plus z2 divided by 2. That's a little bit of a rush 2 there. Let me clean that up. There we go. Okay, so we can use this as our x1, x2, y1, y2, and z1, z2. Or you can use it the other way around, x1, y1, x1, x1, x2, y1, y2, x3, x2, x1, y, oh my goodness, x, z1, z2. I'm mixing up my x's and z's there. Now you see why I keep it pretty basic instead of trying to flip it around. x1, y1, z1, x2, y2, z2. Because if you try and flip it every which way around, you get the right answer, but it's really easy to get confused. So I try to keep it simple. Alright, so if we go ahead and plug those in, x1 is 5, x2 is 0. So we have 5 plus 0 divided by 2. y1, y2, so -2 plus 4 divided by 2. And 3 plus -3 divided by 2. Okay, so if we go ahead and simplify that, we end up with 5 over 2. -2 plus 4 is 2. 2 divided by 2 is 1. 3 plus -3 is 0. 0 divided by 2 is 0. Okay, so this is actually your center. Which, by being your center, means this is your H, your K, and your L. Alright. Now, if you remember your distance formula, or your equation for a circle rather. Instead of this, we're going to use the distance formula, but we're going to use the equation for a circle first. R squared equals, well, I'll use that on the other end just to keep it consistent. X minus h squared plus y minus k squared plus z minus l squared equals r squared. Okay, but we're going to use the distance formula to find our r squared. Okay, we don't know that yet, but we can always use the distance formula because the distance formula, remember, your r squared is just your radius. Okay, so if we can find just our r, we'll find the radius. Okay, so using the distance formula, instead of d, we'll just use r. R equals the square root. Remember, it's x2 minus x1. Okay. So we're looking at the distance. Let me bring this down. We have 0, 4, -3 to our center. That's what we're looking for the distance for. Okay, because that's our radius. All right. So this is your x1, y1, z1. This is your x2, y2, z2. Okay, that will leave us with 0 minus 5/2 squared. Okay. x2 minus x1, y2 minus y1, z2 minus z1 goes from there. Plus, we have 4 minus 1 squared. Plus, you have -3 minus 0 squared. Okay, so that will give us the distance from the center to either point. And actually, you can use this point, you can use this point. I just use this point because it has lower numbers and a 0, which makes stuff a little easier. Okay, but you'll get the same distance either way. Okay, so if you add up all that in there, you will end up with the square root of 97/4. Okay, now remembering this formula here, so r is equal to square root of 97/4, but r squared is just 97/4. Okay, so we have our center and we have our radius, which means we can plug it right into this formula. So we have x minus h, so x minus 5/2 squared, plus y minus k, y minus 1 squared, plus z minus l, so z minus 0 squared, equals r squared, which is 97/4. Okay, so that's your standard equation of a sphere with those 2 points after you find your center. Alright, so that's the end of this problem. Okay, so if you are still writing, feel free to press pause, but we're going to go ahead and move to our next example. Alright, so what if we wanted to show the standard equation of the sphere x squared plus y squared plus z squared plus 8x minus 6y plus 2z plus 17 equals 0. And we want to find its center and radius. Alright, so this one, if you're a little bit rusty on the standard form of an equation, the first thing you want to do is you want to put all of the like terms next to each other. So the x terms you want next to each other, the y terms and the z terms you want next to each other, and the non-variable term, put it on the other side. So we have plus 17 here, put minus 17. Subtract 17 from both sides. Okay, so we're going to move those next to each other. So that becomes x squared plus 8x. Okay, plus y squared. I'm going to give it a little bit of space. Minus 6y. I'm going to show you why I'm going to give it a little space. Then you have plus z squared. Give that a little bit of space too. Plus 2z equals negative 17 if you subtract 17 from both sides. Okay, so all we did was rewrite it. Alright, now why did we give space between each of those? Because each one of these we're going to complete the square. Okay, so remember, you're completing the square is b divided by 2a squared. Okay, so your a is equal to 1, your b is equal to 8. So you have, and you're going to do it for each one of these, you have 8 divided by 2 times 1. So 8 divided by 2 times 1, which is 2 squared, which equals 4 squared. And you're going to remember this value. It's going to come in handy just before you apply the square. So that's going to equal 16. Okay, so we circle that. Then we move on to this one. We do completing the square again for these two. Okay, a is equal to 1. B is equal to negative 6. So that's b divided by 2a squared, which is negative 6, divided by 2 times 1, which is 2 squared. So that's going to equal negative 6 divided by 2 is negative 3. So you have negative 3 squared. And you're going, just like this one, you're going to remember that value. Okay, just before you apply the square. So you end up with 9. Okay, now we're going to do the same thing here. Use the completing the square. So you have b divided by 2a squared. Here, if you notice, b is equal to 2, a is equal to 1. So you have 2 divided by 2 times 1. So 2 divided by 2 squared. Okay, 2 divided by 2 is 1, so you have 1 squared. And again, before you apply the square, you want to remember that value. So 1 squared is just 1. Okay, so what we're going to do is, these three values, we're going to add to both sides of the equal sign. Okay, now remember, we still have these arrows pointing here, these values we want to remember. And it's a really good reason we want to remember those. It makes our work a little later on easier. Okay, so I'm just going to rewrite this the same way with a little bit of space. So you have x squared plus 8x. Move that up a little bit. Give it a little bit of space. And you can have underline it if you want to. Plus y squared minus 6y. Give it a little bit of space. Plus z squared plus 2z. Give it a little bit of space. Equals negative 17. Okay. Now we're going to add this to both sides. We're going to put our 16 because that's our completing the square here. So we have 16, so it's plus 16 here. So we have plus 16 on that side. Okay, this one's 9. We're going to have plus 9 here because it's positive. So that means we're going to plus 9 here. Okay, so we have plus 1 here. So that means we're going to have plus 1 on this side also. Okay, so now right here, we have 3 perfect square trinomials. Okay, so that means we can make this into a perfect square trinomial. So x squared plus 8x plus 16, this is where that remembered value comes in. Tell you to remember that 4. Why? Because these 3 terms just becomes x plus 4 squared. Same thing here. The y squared terms, the y terms. Why did I tell you to remember that negative 3? Because these 3 terms simplify to y minus 3 squared. Same thing here. Why did I tell you to remember that 1? Because these 3 terms end up being z plus 1 squared. Okay, and if you add all of these together, you end up with 9. Because you have negative 17, you have 16 plus 1, which is positive 17. Those add together to give you 0, so you're left with 9. Okay, so that becomes x plus 4 squared plus y minus 3 squared plus z minus 1 squared equals 9. Or you can make that 9 3 squared. If you want, if they wanted it that way, but most of the time 9 is just fine. Okay, so we have our standard equation. Okay, they started with the general equation. Now we have our standard equation. Okay, but we're not done because we still have to find the center and the radius. Okay, but remember, it has to be in the form, just to give you a quick comparison, x minus h squared plus y minus k squared plus z minus l squared equals r squared. These have to be minus signs. All 3 of them have to be minus. Okay, so what do? We rewrite it as minus negative, because that's still plus. Okay, so we have x minus negative 4 squared plus y minus 3 squared plus z minus 1 squared equals 3 squared. Okay, so this gives us our h, our k, and our L, and of course, our R. Okay, now this step here, really important. You'd hate to do all of that work and forget to change those pluses inside parentheses to minus. Okay, that's that last step you don't want to forget. Okay, so that means that our center, which is HKL, is negative 4, 3, negative 1. Well, negative 1. That was z plus 1. Oh, my mistake. I wrote that. That should be z plus 1. So that should be z minus negative 1. I'm sure somebody caught that and was yelling at their screen. There we go. So that should be z plus 1. Alright, so that gives us h negative 4, y is 3, and, well, k is 3, and L is negative 1. And R is equal to 3. Your radius is 3. Alright, so barring that little hiccup that I did right there, this is your answer. Okay, so you have your center and your radius. Alright, so hopefully this little introduction to three-dimensional coordinate systems made sense, and I will see you on the next video.